Yes, hello, good morning. Thank you for giving me the opportunity here to present the question on innovation on high-performance computing in quantum technologies. I'm quite happy that we had the previous presenter just describing how well the high-performance computing is contributing to innovation. I will shed some light on the European dimension of the question and how the European policy on high-performance computing and quantum technologies is contributing not only to the innovation in Europe, but also very specifically in the different member states of the European Union. As the previous presenter explained, high-performance computing is an essential tool for a number of applications in science. Think about climate change, think about cosmology, but also for the industry, for example, simulating car crashes, simulating virtually full airplanes before you start building them, but also for the public sector, for the security, checking the traces of cybersecurity attacks or making your systems more resilient against attacks. But probably one of the most compelling examples of the recent history of the role of supercomputers is helping combating the pandemics that we're going through. The development of the vaccines would have not been possible with the combined computing power of those supercomputers for simulation, for testing, and developing in an unprecedented speed the first vaccines that are really helping to combat the pandemics. The computers were also used, of course, to simulate the propagation of the pandemics, testing models of human behavior. And from there on, we can use the same tools and applications for other medical problems like combating cancer or other medical issues. Just think about the possibility to simulate completely a human body and then start testing some compounds, some medicines to see how the human body will react to those compounds before going actually to clinical trials, which are far more time-consuming and at times far more dangerous also for the patients. The move to exascale, indeed, is one of the key innovation drivers. Whenever you have more computing power, we know by experience it is immediately used up for having more precise applications, more fast response, but also for doing some applications that you could not do with the previous generation of supercomputers. Just let me give the example of simulating the whole Earth, what we call a digital twin of the Earth, to understand how the climate reacts, how the oceans behave, what is the correlation between the different environmental factors, combining this with space data and so on, to a clear understanding of how our planet behaves and simulate how the world would change if we change one or the other parameters. Now, the policy in the European Union on high-performance computing is, I would say, an old story, but started quite some years ago. But in 2018, we made a big step forward in creating a joint undertaking on high-performance computing to pool together the resources at the European level, bringing together European resources and national resources, be it computing resources, be it financial, be it human resources, to tackle collectively an issue that is of vital importance for the Union as such, but also for each country, because nowadays access to high-performance computing is a strategic asset for any country, for any society, for any economy. Access to supercomputing resources in numbers, but also at the level of performance. If you go back 3 years ago, we were one step behind where we are now. We had a number of national programs, a number of national efforts to invest and build HPC ecosystems, but taking individually all those efforts with maybe one or two exceptions were insufficient to really stay at the forefront, stay at the world class in access and availability of high-performance computing resources, be it the availability of the supercomputers themselves, the availability of the applications, or the availability of the skills to exploit those computing powers. we were in Europe lagging behind other regions of the world, like United States or Far East Asia, which were continuously driving the innovation there and leaving us behind. However, with the creation of the UHPC joint undertaking, bringing together the 27 member states of the European Union, plus 3 associated countries and the European Union, managed to have a coherent approach, a coherent strategy of high-performance computing with all its repercussions on the innovation, its repercussions on the value chain. And with the combined effort, in 3 years, we made quite a significant step forward. Just to give you some figures, if you look at the top 500, the listing that is done every 6 months to rank the different supercomputers in the world, even if we are not among the top 3 yet, in the last 3 years, with the installation and putting into service of already 4 petascale supercomputers, the availability and the number of supercomputers in the top 100 has increased dramatically. And those are the smaller scale machines that are jointly acquired with countries. We now have one in Slovenia, we have one in Bulgaria, one in Luxembourg, one in the Czech Republic, one in Portugal to come up, which are moving us quite ahead into the top 100. And with the big 3 supercomputers that are being installed either in Finland or the one in Italy, and hopefully the next one next year in Spain, will bring us back into the top 3, if not top 5 in the world of supercomputing. So this already now we see has a tremendous effect on the innovation capacity of the Union by giving access to any user in Europe to the world-class high-performance computing resources and associated services, including the skills, but it has also a knock-on effect on the research programs we're running at European and national level to develop and prepare the technologies and applications that we need for the current generation, but more and for all, for the next generation of HPC technologies. And we've also seen in this combined acquisition and operation of high-performance computing at the national level, we have seen the huge impact on the innovation this has produced locally on the host countries, which, if I take back the example of Luxembourg, is really a first-comer into the top league of high-performance computing. And we see the whole interest this is generating around the competence center, around the supercomputing center, on access to those machines from science and from industry. Now, of course, this is just what we did for the last 2 or 3 years. The joint undertaking, of course, is continuing with a far larger budget than before. And the plans are, of course, to continuously upgrade and expand the number of supercomputers that are available, be it at the mid-range level, the petascale level, where we'll continue seeing more and more of those supercomputers emerged and installing in the countries across Europe. And would be quite happy if also Slovakia would realize its ambitious plans to have a joint ownership and operation of such a supercomputer. But of course, we're also moving up to the exascale level to really be in the top 3 of the world of supercomputers. All this deployment and installation of supercomputers goes hand in hand with the development of the underlying technology. And that's where we count on having in 2023, if not in 2024 at the latest, the first acquisition operation of high-class, world-class supercomputers that are built essentially on European technology, on technology developments that are coming out of the national programs or part of the European programs. Now, the picture would not be complete if I was not talking to you about quantum computing, which is a new technology we see more and more now converging with the high-performance computing. You might argue that there are no standalone quantum computers yet. The devices, the systems that we have are less performant than the classical computers. However, we are coming at the level where those small-scale quantum computers are mature enough to be actually used on real-life applications, even if the precision of those applications might be low, even if can have superior performance with classical machines. The plans now are to acquire, with the help of the HPC joint undertaking, quantum computers and quantum simulators that will be combined with the classical high-performance computers as a sort of accelerators to have at the end a system where, depending on the type of algorithm, the type of the problem needs to be solved, part of the problem is run on the classical machine, but where it's more effective, it will be done on the quantum accelerator, and then at the end, the codes will be combined again. What we are looking towards is having at the end, in a couple of years, a fully federated infrastructure that connects together the high-performance supercomputers, the classical machines, as well as the quantum machines, combining those with the big data repositories, be it space data from Copernicus, be it the scientific data from the European Open Science Cloud, be it the applications on AI, be it the applications on the digital twins, to have a large high-performance computing data infrastructure that can be accessed via the cloud by any user anywhere in the European Union. The last thing I would like to mention, as we're talking about innovation, the quantum technologies, we have, of course, large programs to help there and foster the innovation beyond the acquisition of the quantum computers that will make available in the HPC joint undertaking. We have a large research and development program on quantum technologies to constantly mature and develop the quantum components that we need to be installed then in the quantum computers that will place at the service of the users, and likewise developing the components for large-scale deployment of quantum communication infrastructure. And we are quite happy to highlight that your country has been present in the quantum technologies for the last 20 years, quite successfully, always present in the activities that the Commission has been implementing in those fields. And we're looking forward of seeing more quantum scientists, more quantum industries popping up in your country that will, through the different infrastructure measures that we're putting in place, that will find also a way to grow and to succeed not only in the European market, but also on the worldwide market. Thank you for your attention, and thank you for accepting that I can give the presentation online rather than coming to your site.
Mr. Kalbe, thank you so much for all this, for enjoying our ETAPA today. Have a nice day. Thank you also for your thoughts.